Check the upper and lower bound of zeros of p of x equals negative x to the fourth minus 3x cubed plus 6x squared minus 4x minus 12. In a separate video, we checked the possible positive and negative zeros of the polynomial using the Descartes' rule of sign, and we saw that this polynomial can have either two positive real and two negative real, or two positive or zero negative real, zero positive or two negative real, or it can have zero positive real or zero negative real. In this case, we're going to check the upper and lower bounds of the zeros of the polynomial. And so first we need to know the possible rational real zeros first. The possible rational real zeros is of the form p over q, where p is a factor of the constant coefficient. The constant coefficient is negative 12. The factor of 12s are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. For example, 3 is a factor of negative 12 because 3 divides negative 12 evenly. Negative 3 is also a factor of negative 12 because negative 3 divides negative 12 evenly as well. The possible value for q's, so factors of the leading coefficient. The leading coefficient is negative 1, so its factors are only plus or minus 1. If we take any number in the first list p and divide it by plus or minus 1, then the possible real rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, and so on, which is simply p. To check if x equals 1 is a real zero, we perform synthetic division. X minus k, so k in this case is 1. We write the coefficient of the polynomial starting with the leading coefficient, negative 1, negative 1x to the fourth, negative 3x cubed, 6x squared, negative 4x, and negative 12. To perform synthetic division, first we bring down the leading coefficient, negative 1, and then we times k. Negative 1 times k, k is 1 in this case, is negative 1. Write the result in the next column, and then add the numbers in that column. Negative 3 plus negative 1 is negative 4, and then repeat. Negative 4 times k is negative 4, and then add, and then 2 times 1 is 2, negative 4 plus 2 is negative 2, negative 2 times 1 is negative 2, and then add. This is not 0. This means x equals 1 is not a real zero. This synthetic division doesn't reveal anything about the upper or the lower bounds of the zeros because the last entries has negative numbers, and also the sign is not alternating from non-negative and non-positive. Next, we perform synthetic division for x equals negative 1, meaning we want to check to see negative 1 is a real zero. So we bring down negative 1. Negative 1 times negative 1 is positive 1, and then add. Negative 2 times negative 1 is positive 2, then add. 2 times negative 1 is negative 8, then add. And then negative 12 times negative 1 is positive 12, then add. And so, yes, since the remainder is 0, x equals -1 is a 0. The last entry in the synthetic division in this case also doesn't tell us anything about the lower and the upper bounds of the zeros because the sign is not alternating. For the synthetic division to reveal something about the upper or the lower bounds of zeros, the last row has to have no negative entry or the sign needs to alternate. Look for those two features. We can keep performing synthetic division, but it is recommended that we write it in the factor form if we find a 0. This is the remainder. The remainder is 0. The quotient is read off from the last entry in the synthetic division. The number on the left-hand side of the remainder is the coefficient of the quotient, and then the number on the left-hand side of it is the coefficient of x, and then the left-hand side of it is the coefficient of x squared, and the left-hand side of it is the coefficient of x cubed. And so we can write negative x to the fourth power minus 3x cubed plus 6x squared minus 4x minus 12 as a factor x plus 1, because k is -1 in this case, times the quotient. The quotient, there is -1 x cubed, there is -2x squared, and then 8x minus 12. Again, the factor is x plus 1, not x minus 1. If we read off the zeros from here, we see that x equals -1 is a 0. This time, at least we reduce the degree for a polynomial into two factors. One is linear and the other one has degree 3 only. Moving on with our search, we now need to check to see if -x cubed minus 2x squared plus 8x minus 12 has any of the number in the remaining list of the possible rational real zeros. And so we would simply perform synthetic division using the quotient only. For example, to check the next number, x equals 2, if this is 0, we perform synthetic division on k equals 2 with the coefficient of the quotient -1, -2, 8, and -12. Bring down -1. -1 times 2 is -2. -2 plus -2 is -4. -4 times 2 is -8. -8 plus 8 is 0. 0 times 2 is 0, and the remainder is -12. And so we know that x equals 2 is not a real zeros. And then we keep doing this. Unfortunately, we check to see if -2 is a 0 by performing synthetic division. The coefficient of the quotients are -1, -2, 8, -12. Bring down -1. -1 times -2 is +2. -2 plus 2 is 0. 0 times -2 is 0. 0 plus 8 is 8. And 8 times -2 is -16. And -16 plus -12 is -28. And so x equals -2 is not a real zeros. And again, each time we want to check to see if the last entry has no negative numbers at all, or at least the signs is alternating between non-positive and non-negative. But in this case, none of those features is present. And so we would keep going.